Okay, the first part of this is a set piece. We've got to turn this into its R alpha form. Okay, so the full method goes like this. We start with the R alpha bit and the R cos of the x plus alpha, and we are going to expand this out. We're going to use the fact that cos of x plus alpha, we know that cos of a plus b, this is in the formula book, is cos a cos b, so cos x cos alpha minus sin x sin alpha. That's just the cos of x plus alpha. I need to multiply it by r, so it's r cos x cos alpha minus r sin x sin alpha, and that's got to equal, okay, so that's this bit here, and it's got to equal 7 cos x minus 24 sin x. So this is 7 cos x minus 24 sin x. Now at this point we've got to be really careful in terms of what we match up with what. I like to use colour here. You can't use coloured pens in the exam, but you can underline things in different ways. So what I've got to do, this term has got a cos x on it. So I've got to find the cos x term over here. Here it is. Yeah, sometimes it's first, sometimes it's second. Okay, so the thing that goes with the cos x's is a 7 on this side. So something's going to equal 7. What is it that has to equal 7? Well, the cos x is the bit that I'm matching. The bit that goes with the cos x is the r and the cos alpha. So we get r cos alpha equals 7. Okay, and the other term is actually going to give me r sin alpha. We always end up finding out what r cos alpha and r sin alpha are, but sometimes the r cos alpha comes from the first term, sometimes it comes from the second term. Okay, let's do some more matching. So the other term is 24 times sine of x. So something is going to equal this 24. Okay, so I've got sine x's there, so that's going to match with this sine x term here. So what have I got with the sine x term here? Well, I've got minus r sine alpha. So I'm going to get minus r sine alpha equals, and on this one I've got minus 24 in front of the sine x, so I'm going to get minus 24. Now of course I could have spotted they were both going to be negative and just written down r sine alpha equals 24. So as promised, I've got an r cos alpha which is 7, and r sine alpha turns out to equal 24. Okay, so how does that help? I want to work out what r and alpha are. Well, there are two things I can do here. Okay, the way to find r is to use the fact that cos squared alpha plus sine squared alpha is 1. So I'm going to be squaring these things. In fact, I'm going to be doing 7 squared plus 24 squared. Okay, well, what does that mean? Well, I'm squaring the 7, so I've got to square this. So I've got to get r squared cos squared alpha. So that's the 7 squared. And then for the 24 squared, that is r squared sine squared alpha. And the reason why I've done this is that this is r squared times cos squared of alpha plus sine squared of alpha. And we know that cos squared of any angle plus sine squared of the same angle is just 1. So this is just r squared. And so therefore r squared equals 7 squared plus 24 squared, which your calculator can tell you is 625. Okay, so therefore r is the square root of 7 squared plus 24 squared, which is the square root of 625, which magically is a nice number 25. Okay, now that is the full method. Okay, now you can see that actually we've now got a shortcut for finding r, because what we've basically done is we've taken that 7 and we've taken that 24 or minus 24, doesn't matter, we've squared them both, added them and square rooted them. In other words, we've done Pythagoras on them. Okay, we've taken 7 and minus 24 and we've Pythagoras them to get 25. And that's worth remembering as a shortcut, because this line here, it's not hard, okay, but you are using a trig identity, and this is a method that always works for r. Okay, let's go on and find alpha. So I know r cos alpha and r sin alpha. Okay, so I am going to work out tan alpha, and I'm going to work out tan alpha by saying that tan alpha is sine alpha over cos alpha. Now I haven't actually got sine alpha or cos alpha individually yet, okay, but I have got r sine alpha and r cos alpha, and they will work just as well. R sine alpha divided by r cos alpha, the r's will cancel, it will still give me tan alpha, and that's got the advantage that tan alpha is going to be r sine alpha. I know that r sine alpha is 24 over 7. So I've got tan alpha. So alpha is just going to be, well, be a little bit careful here. Technically, there are two solutions, aren't there? Because I can inverse tan this, or then I can get the second solution. But what they normally are, and they are here, very kindly, they tell me that alpha is acute. So I'm going to get away with just considering inverse tan of 24 over 7. So inverse tan of 24 over 7, my calculator will tell me. And it turns out that it is 73.7 degrees. Okay. So, okay, there's a shortcut method for r, which is the square root of this number squared plus this number squared, this number squared plus this number squared. Now that always works. Now tan of alpha turned out to be this number here, again ignoring the sign, divided by that number. Okay, but sometimes it'll be the first number divided by the second number. Okay, so I strongly recommend you get there will be method marks for getting this far in the solution. Okay, after that, if you bail out and just use this method for r, which you could have done from the beginning anyway, all right, you will get the mark for r. Even if this didn't appear, you'll get 1 mark for getting the right value for r. Okay, and if you're really stuck, you know that one of these values divided by the other, inverse tanned, okay, will give you the right value for alpha. And you could even try and substitute in your r and your alpha and any value you like for x and just check that it works. So you could actually try tan alpha both ways up if you've completely forgotten what to do, all right? But the bits that I think you should build into your solution, okay, I'm doing them in red, but these bits in blue. So all of that bit in blue, this line here, so this bit in blue here, and all of this in blue here. So I think you should be setting up r sine alpha and r cos alpha and doing tan alpha as r sine alpha over r cos alpha. I think that's the minimum kind of acceptable method, really. But there are kind of desperation things you can do, because there will always be a follow-up. In this particular case, for A2, we've got to now solve an equation. Okay, now hopefully your writing's a bit smaller than mine, and you can fit all of that into the space in your notes, but I'm going to now need to carry on separate paper. Okay, so we're now solving that equals 10. So something has got to equal 10. So what is it that's going to have to equal 10? Well, actually, did I finish this off? Not quite. I found r and I found alpha. You might get away with just stating r and alpha, but it says put it in this form. So it should be r times cos of x plus the alpha. So therefore, my answer should be r, which is 25, okay, times cos of brackets x plus the alpha, which is 73.7 degrees. X is a variable. There's no single value for x. This is equal. This is true that this equals this thing for every single value of x. Okay, so this, for the equation, this is an alternative way of writing my 7 cos x minus 24 sin x is what's got to equal 10, but instead of using that form, I'm now going to use this form. So, going back to my other bit of paper, I've just got to transfer that in. So the equation I'm actually solving is that 25 times cos of brackets x plus 73.7 degrees has got to equal 10. Okay, now the given range was that we're solving for the interval 0 is less than x is less than 360 degrees. So therefore the thing in the brackets, my x plus 73.7 degrees, I've got 73.7 degrees is less than or equal to the bracket is less than or equal to 433.7 degrees. So that's going to help me get all the solutions correctly in the range. Now I'm going to work out what cos of the bracket is. So cos of x plus 73.7 degrees equals 10 over 25. So this is the method that you learned in Core 2 when you're solving a trig equation and the thing in the bracket isn't just a plain x. So sometimes you use another letter for what's in the brackets. I haven't bothered this time. So x plus 73.7 degrees. Okay, well, it could be inverse cos of 10 over 25. Okay. That's my first solution. And it's important that we get all the solutions for the bracket. So what I don't do is leap towards getting a value for x. I get my second solution set up first. So the other thing that x plus 73.7 degrees is, well, you use a cos graph, or you use whatever your favourite method is of getting the second solution. In degrees, it's 360 minus that first value. So what is inverse cos of 10 over 25? Of course, 10 over 25 is 0.4. Okay, it's a simple fractional, 2/5. The answer is, this is 66.4 degrees. So my second solution for the bracket is 360 degrees minus 66.4 degrees, which is 293.6 degrees. But notice, I'll say it again, I have not got a solution for x first. I've got two solutions for the bracket. Are there going to be any other solutions for the bracket? In fact, this one isn't in the range, is it? So this is fine. It's a perfectly valid solution. But to get solutions in the range, I'm going to need a 360 degree repeat of that one. Okay, so my x plus 73.7 degrees is going to equal the 293.6 degrees is fine, and the 360 degree repeat of that is 426.4 degrees. I've just added 360 on, which is in the range of values I wanted. So now to finish my solution, I've just got to get my x values by subtracting the 73.7 degrees. Okay, so I'm going to get 200, and it's not quite 20, it's 219.9 degrees, and this other one is going to be, take away 73, it's going to be 354.7 degrees. And I hope those are accurate to one decimal place. Ideally, I wouldn't have rounded these to one decimal place, but I think I'm going to get away with that. So those are my two solutions.